frame is a structure made of beams. And truss, which is a simple one, and we discussed it after Newton 2, is a structure made of bars. So what are beams and bars, and what's the difference? So a beam has a specially designed cross section, as we can see, that can accept shear forces. So this is an I-beam, and what you can do, you can apply both axial and a shear load anywhere along the beam. So if that's a beam, let's say this one is structure, the simplest one, the beam fixed to the wall, like it's like welded to the wall. You can have a force here, you can have a force here, you can have a force like that, and you can have a force here in the middle like that. And you can have a moment, you can have a torque. So this kind of like a very robust component in the structure. You can accept all kind of loading without failure. The bar, however, is simply a thin and long part that is designed only to accept axial loads. So if you have a bar like that, and let's say you have a structure, it's a truss. You connect a bunch of them together. This is your house, bar, truss, right? Connect a bunch of these structures together, these compound bars together is a bar. And this is a beam. Well, in this case, this guy can only accept axial load, either tension like that or compression, right? You can't put a force, shear force like this. It's gonna break. This is not designed. So in your analysis, you never consider an axial shear load, a cross load. It's only axial. So it turns out the analysis of truss is way simpler than frames. But today, before we do truss, which is a simpler one, actually your book does it. You first does the truss and then go to frame.
So safe to say beams are load bearing and bars aren't?
Huh?
Safe to say that beams or frames are load bearing and bars can't bear load? Because you're saying if you put weight in the center of a bar, then it'll break, right?
Yeah.
So beams are load bearing and bars aren't? Okay.
And this is a load bearing version of bars, right?
Yeah.
This one can accept the load, but the load should be always at the end, like the pins. Yeah. It cannot be somewhere in the middle. This guy can accept some load in the middle. So I can say that this is more general than this, but because this minimizes the weight, these are very thin and it's not heavy. So it can help you to design a structure that is very, very lighter than beam design structure. So if your design variable is weight, you may consider adding a truss to your components. But if you don't have weight limitation, you go by beam. There are some other parameters, cost of construction cost. They can also be one of the costs, right? So what I'm saying, the analysis of this section for truss is usually simpler than frame. We're gonna end up with a very specific algorithms to solve truss, which are easy. It's called method of section, and the other one called method of joints. And this is a subcategory of 5 steps. So our general 5 step is always applicable, any problem. But it turns out for truss, later, we actually reduce that 5 step to a very simple algorithm that you don't even need to do 5 steps every single time. You just do that particular algorithm, which is subclass of the 5 step. But still, you're doing 5 steps. but you just ignore a lot of things, and you do truss analysis. But frame, you cannot get a simpler algorithm. You have to do 5 steps. So although this is harder than truss, but I do it right now because we just finished the free body diagram. We just finished the 5 steps. We already solved some 5-step problem, a lot of 5-step problems. So let's go to the frame, which is a continuation to the 5 steps, and then we go to truss, which is very easier than this. So the reason that I first do frame and truss is because this is the more advanced part of the 5-step algorithm that you already know how to do, right? So the first example of the frame, let's say you have 2 beams, beam number 1 and connected to beam number 2, and the bolts, pin, and the wall. So let's label this 1. Let's put it here, and 2. And then we're going to have some load. We're going to have a mass here, 10 kilograms. This is hanging on this point. Let's say there is another distributed load. Yes. This is 3K. And there is, of course, some components. Other moment with that. Applied at that point. And let's say this distance is 3 meters. This distance 4 meters, and this is at the middle of this. So this 1.5. And also this is at the middle of this guy. So it's 1.5. So yes, this is a frame. According to definition, each one of these 1 and 2 members is member 1, member 2. They're both beams. They're pinned at these points. We can then replace ABC, A, B, C, so pinned together. And then we have some sort of external loading. Right? Here, distributed triangular load. Couple moment, this couple, this on the force. And the weight, 10 kilograms hanging on from one of these beams. Obviously, this can have shear load, you see, at somewhere between. If this was a bar, a truss, it could not accept loads here. It could only accept the force at the ends. Because at the end, you should get compression load or tension. So my problem here is find the force at point ABC. A, B, C. Find reactions and these 3 pins, A, B, C. Now what should I do? I believe that you should be able to solve it right now. Without even all we do, we just try and solve more example, right? To give you some exercise.
Break it up
So
in
practice.
systems.
Yeah, so again, we know, we already know 5 steps. That thing is always valid. That thing is always valid regardless, right? So the first step, choose system, draw free body diagram per system, write equation per system, and write equation for all system. Before you go, you solve it. That's the secret, right? And then solve the equations, and then verify your result if you can, right? So the first thing I do is to draw FBD, right? So I'm gonna take, this is bar 1 and bar 2, and I'm gonna get this weight as system 3. So that's my system 1, system 1, system 2, and system 3. Now, the next step, free body diagram per system. So again, if that's the border of our system, border of system 1, border of system 2, border of system 3. So I start picking a point, walk on the border to get surface force. Once I'm done with surface force, I go to body force. So 2 steps. So start walking from here. The first point you call is B. So how many force and moment do you have there?
2.
2. Thank you. Dx, dy. Continue walking. Then you cut this guy. This is the load. Every time you see this with load, what should I do? Replace it with point load. Right? So the point load is going to be 3 times this base, which is 2. So 3 times 2, 6 divided by 2, 3. So it's going to be 3K, 3 kilonewton force, and acting at 1/3 of this base. Right? If this base is 2, it's going to be 2/3. 2/3 from here, and the value is 3K. Let's use a different color for the distance. So it's going to be 1/3 of 2, and that's going to be 2K. Now continue walking. Then you cut C. How many force and moment at pin C is a pin? Frictionless pin.
This should be 1. Right.
Every time.
Oh, it's a frictionless bend, so it has 2. It has back to the 1.
Yeah.
Yeah.
You see? So it's going to have a CX, CY. Just introduce 2 unknowns, CX, CY. Don't try to figure out what direction. This way, you just choose something and solve. At the end, you get either positive or negative. And if it's negative at the end, that means the actual physical value is opposite to the direction you initially chose. So you're not going to miss anything. Just choose something like that. Right? Then continue walk. Now you come to the start point. So you're done with surface forces. Now we go to body force. These beams, let's assume that they are massless. So what's the body force?
0.
0. Alright, so that's my FPD for system 1. Now let's go to system 2. Again, pick this point. Let's start walking. So here you're going to get AX, 2 forces, AY. Then walk all the way. You come here. Again, here you have 2 forces, but look, we already have them right here. So all you do is just use them. But according to Newton's third law, there's law of action and reaction. They're going to be exactly the same here, but it's opposite. Right? So here it's the same thing, but opposite CX, the same thing opposite CY. And you're right there. Then you come and cut this torque here. So you have a 2K torque. This torque is not a force. At that point, then you come to this point, cut this tape cable, right? Do I know the force in this cable? No, right now I haven't solved anything. Do I know the force in this cable? Like if you had a gauge here, you could read the force, yes, but you don't have anything here. No sensor, no gauge, nothing, right? So I don't have it, I'll just introduce T1, force in cable 1. We can just say T, right? Now continue walking and you come back to the start point.
How did you get 2/3 for the first system?
Well, in this triangle, right, the force is 1/3 of the base, right? And what's the value of the base? From here to
2.
here? 2. So it's going to be 1/3 of 2 from here.
Okay.
So it's going to be 2/3.
Okay.
1/3 of 2 is 2/3.
Okay.
Right? So here, I'm done. with surface force. What about body force? Mass of beam, let's say, is small. Every time you have to check, you have to go read the question, see if I put a mass for a beam or not. If I don't, the same beams are massless, you just don't put extra force. Otherwise, you're gonna put a gravity force here, which is mg, the mass of beam.
Is there a reason why CX and CY are opposite directions in the two systems?
Yeah.
Is it
The reason is the Newton third law. Let's say these two are connected here, right? And I try to pull this guy, right? So this guy is going to pull the system this way. So the force, if I put the force of this on this, is this way. But also this guy is trying to put the other one too. So if I go to this system and look at the force of the system, the force is this way.
Okay.
It's the law of action and reaction, Newton's third law. Right? Okay. So now we go to system 3. So this is my system 3. Pick a point on the border, start walking. Look, I need to see all these things in your answers. Like if you solve a problem and your answer is just a number, and don't bring the explanation, I can't grade it. I cannot. I will fail to grade it. So I want to see the details, how you got it, right? So here, pick a point, go to find surface force. The first thing caught here is
T1.
Yeah, the tension in the cable. But I already have a T1 here, so I just use it. I don't need to use T2 or another cable. Because it just, I already have it, right? So you put T1 this way, walk, you come back here. No other surface forces. But what about body force? Do I have body force?
Yes.
Yes. And this value is equal to 10 times 9.81, which is 98.1 newtons. Alright? So that's all. That's my step 2, which is free body diagram. So I've already done step 1, choosing the system. I end up with 3 systems. Step 2, draw free body diagram. I already did it. Now step 3 is what?
Equations.
Equations. But look, before we go and write the equations, we do some sort of feasibility study. You remember we said we do some sort of bookkeeping, see if you have enough equation on unknown. And if you don't have enough equation, you just don't bother to go to write the rest of it, right? It's a good coincidence that, hey, you know, I don't have enough equation, so it's indeterminate and I stop. And you go to the next question. It's good for you. So let's see if that happens or not. Let's see if you have enough equation to solve the system or not. So how many unknowns do I have? 1, 2, 3, 4. Again, 3, 4. Right? 5, 6, 7, and 8.
Was that not the
Or
same
what?
number?
7, 6, 7.
Yeah.
7. This is already counted in. So 7 unknowns. So how many equations do I have?
9.
9. So the number of equations, although we get a lot of null equation here, so it turns out that I have enough equations. So if I don't have enough, let's say the number of unknowns was 12. You start counting like that, the number of unknowns is 12. And your equation is maximum 1, 2, 3 times 3, 9. Then you just say indeterminate, stop, and you go to the next question. You simply don't get your hand dirty in solving it. That will greatly save your time. Now I have enough equations, so I have to go to step 3, which is writing the equation. So let's write the equation for system 1. Summation of force in x0. So that would give me cx plus bx is equal to 0. Summation of force in y0. That would give me cy minus 3k plus by equal to 0. moment around any point is 0. Well, we talk about a strategy that you should pick a point that most of unknowns are passing through that point. So it turned out that among this and this and this, these 2 points are strategically better. Right? It gives you the simplest possible equation. I choose this point. It's your choice, right? So if I choose B, then I put the sub B here. See it? So for that, it becomes 3K times this distance. So this distance is 4 minus 2/3. Right? Positive or negative?
Negative.
Negative. How about this? Bx, 0. Going through that. By, 0. Cx,
0.
0. It goes through that point, right? So the only thing is Cy. Cy times 4Cy. Positive or negative?
Positive.
Positive. Is equal to 0. You see that? Here, it may be very tempting to say, oh, you know what, I've got one equation, one unknown. So let's just solve get Cy. Don't solve it. You have an extra step for solving, just for solving, right? Now let's go to system 2. System 2, summation of 4. X0 is equal to AX plus negative Cx. So from here, AX negative Cx is equal to 0. Summation of function y 0. And this gives me a y negative t1 negative cy equal to 0. Summation of moment around any point, but I take a 0 and give you t1 times. So first, what's the moment of ax? 0. Ay, 0. They're going through that point, right? For this guy, I have to do the standard moving procedure. Where should I move it?
Down.
All the way down. So it's going to be this distance. So if that's 4,
So-
right? That distance is going to be
A third of it?
2. Assuming it's perfectly at the
Oh,
center,
2. Okay.
right? Positive or negative?
Negative.
Negative. Now go to the next one. What should I do with this cover moment? Minus 2K, just add it. You don't need the arm. It's already a moment, right? Negative 2K. Right? And then
0.
this guy,
It's going through.
this goes all the way here. So it's going to be Cx time. Positive or negative? Positive. What about this guy? What about Cy? Move it down, right? It's going to be Cy times 4.
4.
Positive or negative?
Negative.
Thank you, negative. Is equal to 0. So these are equations for system 2. Now let's go to system 3. Summation of force in the x direction, 0. This equation is what? The norm equation. 0 is equal to 0. It's not going to help you. Summation of force in y direction is 0. That's going to give you T1 minus 98.1 is equal to 0. And summation of moment around any point, 0. Let's say I pick a point at the very center. So I get summation of moment, which is equal to already 0. And the moments are all 0. So 0 is equal to 0 is another null equation. Another null equation. So you don't even use this guy, right? So let's label all the equations. So let's say this is equation 1, 2, 3, 4, 5, 6, 7. How many equations do I have? 7. How many unknowns?
7.
7. So I'm right now ready to just get the numerical answer and finish the problem. So which equation should I start with? 7. So is that the only thing I can solve it?
No.
What else? What is equation number 3? That's my other option. So usually, when you want to solve, you only have one way to get in, and it's not necessarily not in your system 1. It could be somewhere in one of those systems, but you always get one equation, one unknown to get in. All right. So here, let's start. But here we have 2 possibilities. So this problem is very easy. We have 2 possibilities to start solving the problem, right? So t is equal to, if you solve this equation, let's use blue for solutions. Then that would give you t1 is equal to 98.1. Now what is my next option? Can I do this?
No.
No. How about this one?
No.
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 Yes.
Yes.
Yeah. So let's do it. So this equation cy is equal to 3k times 4 minus 2 over 3 divided by 4. And that is, put it in calculator, 2500 K. K or just 2500? Oh, so that's 2.5 K. 2.5 K. Right? Or 2500. Okay? So now what's my, so that's my CY. Right? So what's my next step? 5. Right? You could have more options.
You could solve 5, you
You
could solve
have,
2.
You could have, no, maybe it's only 5.
You could do
So
2.
AY
You could solve 2.
is equal to solve 2. Yeah. Well, you can solve 2 too. So 2 or 5. So I solve 5. There is no, there is no priority. Like which one solve? Well, if you can solve it, just choose one, solve, go to the next one. Right? So AY is T1 plus CY. It's equal to 1.5K plus 98.1. So that's going to give you 2,598.1. Calculator, I messed it up with solar system. 2.5. Alright, it's going to be 2,000. Now, what is my next step? You can do this way, right? So Vy is equal to 3K minus Cy. 3K minus Cy 2.5K. So that's going to give you 0.5K or 500 newtons. Now, can I solve equation number 1? Can I solve equation 1 or not? No. So which one should I solve next? Equation number 6. All right. So here Cx equal to 4CY plus 2K plus 2T1 divided by 3. 4 times 2.5K plus 2K plus 2 times 98.1 divided by 3. That's going to give you 4,065. Okay. 4.065, just 4K, right? The thing that this question have, if you have K, don't forget to write it down. It's 1,000. Because you're gonna have forces like T, they are not the order of K. They are simply 98.1. So if you don't write K, this is actually when you add, for example, By to T1, you're adding 3,000 to 98.1. And that's almost 3,000. But if you don't write K, you think that you're adding 3 to 9.
Mm-hmm.
And that makes a significant error. So if you have K, just write it down. But let's say in your problem, everything, all the force and moment, you have K. You can just drop K from the beginning before you start, solve the problem without K, and then final answer is a fraction of K, right? Because you factor it out, just bring it back. Like if your final answer is 2.1, then it's 2.1 K, because you factor the K from the beginning, right? So this is your CX. Now can I do equation 1? Finally.
Yes.
Yeah, so if I ask you, find Bx, right? You can't get Bx from, like, oh, okay, if you have Bx, then, well, I can do it with one equation, right? You can't do that. Now, let's give you another midterm waiver. Can you do Bx with one equation? Let's say I give this problem to you, right? And I say find the reaction at point B in the x direction just with one equation. Well, obviously, if you look at this and say, well, I had to go through all of the question, through all the lines, to get to this point that finally I get Bx is equal to negative Cx, which is whatever that thing, negative 4.065K. Well, so no. I can't solve Bx with one equation. If you give me this, and I haven't done anything, I cannot solve this with one line. Well, that's what you think, right? But now, I give you another midterm waiver. Can you get Bx with just one line? Without using this, just start over. This is your problem. Can you get Bx with just one equation, one line? No. Huh? Should I start counting 1 to 10 and then I do it myself? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, I do it myself. You miss another midterm opportunity. Midterm waiver, it can be very extremely helpful for some students who didn't make a good midterm grade. Now, with one question like that, you can get 100% with your midterm grade. Isn't that amazing? So let's think about it. I have to think like that. If I break it down into 3, 4 systems like the way I did, I have to go through everything, then to come back to 1 and get Vx. So if you think like this way,
Let's keep that one
for the
system.
student that they try to memorize things, you can never solve it in one line. But look, the first step in the solution procedure is choose your system. Do you remember that? I insist one more time. Choose your system. That's what I chose. I chose every part of the system. Now let's say if I choose one system, if I choose entire thing as a system. Now let's grab, here we have green, blue, red. Let's grab a different color. Hope I wish I had a purple color. Different color. Maybe we can do it with green. Yeah. Let's choose the entire thing as a system. Right? There you go. Right? Now I want to draw free body diagram. So again, going back to, again, we're not doing magic. Again, it's 5 steps. There's nothing in this course and other courses you're gonna have until you go to the postdoctoral degree. Nothing's gonna be outside of the 5 steps. Everything is inside this framework, right? So again, I'm working in 5 steps, but look, I start over and choose everything as my system. And then the next step is free body diagram. So I want to draw free body diagram. So I make a rough representation, make it as simple as you can. So that's my system. Now let's start. What should I do in order to draw a free body diagram for a system?
Start walking.
2 steps, surface force, body force, right? Surface force, to start walking. So pick a point like here and start walking. The first thing, so I will start walking from here. The first thing you cut, point B. How many forces and moment do I have?
2.
2. So you're gonna put 2, let's use green now. Do I know them? No. EX, EY. Well, you may say, well, I already know what BX and BY is, but look, let's say we solve over from scratch and we want to solve the problem with one line. So you're gonna have 2 unknowns, BX, BY. Continue walking. What else? You cut this external triangular load coming from the surrounding. So you replace it with, value is 3K, and this distance is, let's consider now this distance. This distance is 4 minus 2 over 3. Okay? Now continue walking. Look, this is now inside my system. You see that? The CX and CY that we had here, because they are inside the system, my dash line are going around them. They are inside the system. The interior force, whatever inside, we don't care because they cancel out. We're just getting the forces that come from the neighbors to the system, the external, the exterior coming to the system. So we don't have anything here. Now, if you go like that, you see that this guy also, there is a guy, although this doesn't go here, but there is a shaft or something coming here that somebody is applying a torque, right? So if you have a dash line, this is like a 3-dimensional wrapper, like around the system. That dash line will cut the effect of the torque that the guy is applying here, right? So you have to include that, that's external. So 2K, you put 2K here, That's the external one, 2 kilonewton times meter. And then you're not gonna cut anything. You're not gonna cut anything. Then you come to this point. Here you have two forces and moments. Two forces, no moments. So AX, AY, right, two components. And then you come back to the start point. So you're done with the surface force. Now what about body force? There is a body force, even though if you ignore the mass of this guy and the mass of this guy, there is a mass here. Alright? So there is a body force. So in this system, I put a body force too, which is right here. Right? Let's put it here. And this is 98 mg/1. And I know the distance. The distance is from here is 2. Right? So if I measure from here, this line, this distance is 2 meters. Right? So that's it. That's my free body diagram. So how can I find Bx with one line? Now I have new system, new FPD. So let's say this is my FPD. How can I find Bx with one line?
You can't. You got 4 unknowns and you only 3
yeah,
equations.
but look, if you write, what about moment about A, as Dawson said? Moment about A. You see that? So summation of moment about A is equal to what? Let's start with AX. 0 is going through A. What about AY? 0. Going through that. What about this guy, BY? 0 is going through A. What about BX?
0.
3.
BX has a moment on it.
Oh yeah, it does.
So BX times distance. And the distance is 3. Positive or negative? Negative, thank you. And this guy, move it. Move it here. So the distance is going to be 4 minus 2 over 3 times 3. And also don't forget, when I write 3, you should put K, right? Because you have 98.1, which doesn't have a K. So you have to put K, right? So positive or negative? Negative. What else? Minus 2K. Right? It has a K here. Then the next thing.
Minus 98. Yeah, 98.
Minus 2 times 9.81 is equal to 0. So in fact, this equation, how many unknowns do we have in this equation? 1. One equation, 1 unknown. So Bx is equal to?
It should be 98.1.
Yeah, 98.1. Dx is equal to 4 minus 2 over 3 minus 3 kilograms. With the negative sign. Minus 2k. Minus 2. 98.1 divided by 3. That's it. So, as you can see, we solve it with one equation. This is what I'm using. So what was the key? Choosing the system. That was the key. So with the wrong system, we end up with lots of equations, and we may solve, it may consume a lot of time. Look, if you work in a company, you don't have enough time. You should be quick, you should be fast. But with the right choice of system, you get minimum number of equations, which is just one line. So here's the thing, in your book, it doesn't say, it doesn't insist on choosing the system. It has minimum effort to show you how to choose the system correctly, which is the only bad part of the book. The rest of it is pretty good. It's a very good book. The only part is it doesn't elaborate on the choice of system like the way we did here. But you can see that with choosing the right system, which is open to you, that's the decision you make. You get a lot of simplification. Yeah.
So when looking for, before we start like writing our equations down, and say we use one system and we see that there's more variables than equations, so we look at UIVX, and then do we have to like find a moment about a certain point and see if that will give us less variables first?
Yeah, because originally what you said is we have more unknowns than equations, then we can't solve it. So if we look at that, right now we see that we have 4 unknowns with only 3 equations. If we look at that free body diagram, so that kind of negates what we just learned.
Well, the thing is, before you actually solve it, you want to make sure you get all the equations for all the systems, right? So if I have 3 systems, I did, as you can see, I didn't stop. After I got, you see the equation, system 1, I got it, I didn't stop and solve them. I went to system 2, system 3, system 4, I got all my equations, and then I went to the solve step. That's the reason I have step number 4 is solve. I put a separate step just for solving the equation, right? Because you have to see all the equations. And now here, you have just one system, and it turned out that you have 3 equations, but 4 unknown. And the answer is yes, you cannot solve all of them. But you may be able to solve for one of them. And in particular, the question was not to find bx, by, ax, ay, and whatever. The question was just find bx. And you see that with just one moment equation about a, you get rid of everything except bx. So you get one equation, one unknown. You see? So the choice of system, the more you practice, the better you become at choosing your system.
So in essence, because they only ask for bx, then in essence we have 1 unknown, 3 equations. No? Is that, or am I just?
Say that one
The
time.
unknown is bx, right? Because
Yeah.
the question said what, so in
Yeah.
essence we only have 1 unknown, and then technically we still have 3 equations. We could walk down that 3 equations, but we still
Yeah.
one unknown.
But look, that may not be, although you have 3 equations, but because you have 4 unknown, that one unknown that I choose is not necessarily that you can have one equation
Can
for
have,
you to
yeah.
solve it, right? So you should change your system. But let's say this doesn't work. Then you may just take this guy with mass as a system. Then you would have 2 unknown here, because this is external, and 2 unknown here. Right? And solve it. If I was interested to get something right here. But I know that these 2, because I'm interested in bx, this section should be part of some system, which I don't know. It's kind of iterative procedure. You see what part you can get rid of most unknowns. You actually kind of see through all the steps before you do it. All right.